never underestimate the power of a discovery process of a new tool you'll be using. And the tool we will discover together today is Swift Package Manager, also known as SPM. My name is Antonio. I have been involved in iOS for quite some time now. And besides my full-time job, I like to lecture iOS at my former university in Zagreb, Croatia, where I come from, and also work on some of my personal projects as well. Today's talk will consist of 4 chapters. In the first chapter, I will take you through the process me and my team go through when we decide which architecture will we use for a new project. And then we will see some of the problems we've encountered with a specific architecture. In the second chapter, the maze, I will take you all through the maze me and my team went through, and I will show you what we've learned through the process, and we'll see if we successfully exited together. And if we do, we will use all the knowledge that we've gained in the third chapter, where we will completely morph our project from the ground up. And in the last chapter, we will see what was the legacy of this process that we've done on our project in raw numbers, in time costs, in price costs, and so on. So, the beginning of every project starts with understanding what are the specific requirements for that project. And we use those requirements to create an architecture. And there are several factors which are taken into consideration. Those factors can range from the need that your app works in an offline mode, to maybe the need for an accessibility for your users. And once you gather all the requirements and the factors that you need to account for, you apply critical thinking and think of an architecture which will suit your project. And the project we will talk about today is Project X. I decided to keep it a no-name project because the name isn't important for us today, but what are these details. The project started a little bit more than 3 years ago, and the initial team consisted only of 2 iOS developers. And to pick the best way to show you how me and my team decided to create the architecture for my team, I decided to actually take you on that path with us. So, there were several decisions we've had to make. Yeah, any similarity with physical beings is completely consequential. Yeah, so first we had to decide whether we'll use SwiftUI or UIKit. And since we are talking about 2021, when SwiftUI wasn't as stable, we went with the safer option, UIKit. The second decision we had to make was whether we'll build fully native apps for Android and iOS respectively, or whether we'll use Kotlin multi-platform to build business logic once and then reuse it for the native UI parts. And since all of the factors that we've accounted for went in the favor of going Kotlin multi-platform, and since me and my team have been pioneers of using Kotlin multi-platform even before it reached its first stable 1.0.0 version, we decided to go with KMM. The next decision we've had to make was whether we'll use CocoaPods or SPM, and this was a simple choice for us because we were much more comfortable working with CocoaPods, so we went with CocoaPods. And finally, we had to decide whether we'll create this app as a monolith or whether we'll use a modularized approach. And thankfully, we've decided to use a monolith approach because that's the main reason I'm here today, because, yeah, it's a modularization talk. So, just to sum everything up, we've used UIKit, we've used Kotlin multi-platform, CocoaPods, and finally, a monolith architecture. And since I'm pretty sure that you're all familiar with the first 3 terms, the last one may need a little bit more explanation. So it's a term which isn't only used in a programming dialect, but in common language as well. It's a term which describes something that is uniform, massive, and is able to stand by itself. And when we switch to the programming dialect, the definition doesn't differentiate much. Monolith in iOS represents also a big block, which is uniform, which can stand by itself, but we are no longer talking about stone or metal, but we are talking about code. And of course, this large block of code is created of several smaller subcomponents, but it's almost as if there are no strict lines in between them, as if they are completely coherent, meaning you can use functionalities from one feature in another, you can use component from a feature 2 inside of your feature 3, and so on and so on. A more practical example on how a monolith would look like as an iOS project is that you have your main folder, and inside of that main folder you do have several other subfolders, and as I've said, nothing is stopping you to use functionalities from one folder into another. And it's also interesting to say that the monolithic approach is the one you probably all went with if you've ever created an Xcode project from scratch. Because when you create it from scratch, you by default get a monolith architecture. And now, this kind of architecture probably works pretty good if your project is just starting out. But the Project X we are talking about today grew rapidly. In just a year and a half, there were tens of thousands of lines of code. Our team also grew, so we are no longer talking about only 2 iOS developers, but there were 5 now, which percentage-wise is a pretty big increase. And if this project was about to stagnate for the following period, we would probably just leave it as is. But we've had the information from the client we were building this project for, that there will be a lot of new features that will come in the future that we'll have to develop, which meant that me and my team will spend a lot of time working on this project as well. So we thought, if there are any problems that we should fix, it would probably be good to fix them as soon as possible, because it will be easier, and we wouldn't prolong the pain anymore. So we decided to define those problems, to maybe jot them down, and then when we are completely aware of what the problems are, it would be maybe easier for us to solve them. So let's look at those problems. First of which are those merge conflicts in Project PBX profile. I'm pretty sure you're all familiar with them, and if you're not, I mean, lucky you. Another thing which also occurred is that our components started to get really entangled. And I couldn't resist to do this now and to say that we started to create la spaghetti code. I had to do it. We are in Italy. So, as we've said, our functionalities from one feature could be used in another feature, which meant that we were starting to disobey solid principles. We didn't really follow the separation of concerns, et cetera, and our coding practices were kind of getting worse. Another problem that we've encountered is that our local clean build time grew, which is normal for a project that is also growing. But these were the numbers that shouldn't be accompanied with the size of the project that we've had. Not only the clean build time, but also the incremental build time. And naturally, what follows those two are the CI/CD build times, which also grew. And all of this together resulted in our project getting even more complex than it should be, and it started to bug us on a daily basis to work on it. So we decided to look for tools which may help solve some of these problems, if not all of them. And we found a tool, and we'll get to the solution. But before we get to it, I would now like to ask all of you to interact with me a little bit, to play a simple game with me. The game has only 3 rules. First rule being, you close your eyes. Second rule being, you follow my voice. And the third rule being, you try not to fall asleep because it's the end of the day, and you're all so tired now, I know. So, please, let's start the game. The game starts now. You can all close your eyes, take a deep breath, exhale, relax, and follow my voice. Imagine you are in a dark place, surrounded by tight walls. You get up, you make a few steps forward, and you realize that you've come up to an intersection. You can turn right, you can turn left, but they are both completely symmetrical. So you decide to follow your gut feeling and you turn left. And you do a few more steps forward, come up to another intersection, and this time you turn right. And you move forward and you come up to another one and another one and another one. You start breathing faster, you start walking faster, you feel your heart rate increasing, and you start panicking because you realize you're in a labyrinth, in a maze. And just as you are about to stop and take a breath, you hear a calm, soothing voice tell you, turn left. And you decide to listen to that voice, and in the next intersection, you do turn left. And you move forward, and once again, the voice tells you, turn right. And you once again listen to it, and again, and again, and again, and you realize that you've reached the end of the maze by following this voice, and you feel a huge relief. Perfect. You can all open your eyes now. The game is over. I'm pretty sure that you have so many questions now, one of which maybe is this guy crazy? What were we doing right now? But, I will try to answer two specific questions. First of which being, what does the maze represent? And the second of them being, who the hell told us to go left or to go right? And we'll find the answers to those questions by the end of the next chapter, the maze. So, as it often happens with Apple, on a beautiful sunny day, we've seen that beautiful graph where they showcase their new technology by metrics which are unknown to anyone. But the graph looks beautiful, and we decided to look into it. We decided to see what this SPM thing is. And I'm going to tell you right now that we've used it to modularize our application, our project, that it solved many of our problems, and we can end the talk now, okay? No? Okay. Yeah, what would be the fun in it? We won't end the talk now, because we will use this opportunity, I will use this opportunity to share all the valuable insights, the stepping stones that me and my team went through while we were modularizing our project, and to share them with you to spare you time and effort so that when you start and if you decide to modularize your project, you do it more efficiently. So, the best way to start understanding SPM is to understand what are the building blocks of SPM. So, we're now looking at something similar that we've seen before, but we are no longer looking at a dotted line. We're now looking at a full line that surrounds our feature modules. And that means, or it should at least mean, that these blocks of code contain logic which represents a logical unit that can work by itself, but with the help of SPM can also work as a whole. And you can see that we have several types of modules. So we'll start explaining the way me and my team structured them from the top to bottom. So the topmost module is called core. In this module, we've placed all the code that is shared across the app, like environment variables, extensions, and components that should be accessible from any place of your app. It is important that this module doesn't depend on any other, and that it is the highest in the hierarchy. Right below it comes Core UI, which is fairly similar to the core module because it also contains components which are shared across the app. But this time, we are only talking about components, functionalities, extensions, which are directly UI related, meaning if you have a primary button configuration and you reuse that button in your entire app, Core UI would be a perfect place to store that configuration. It only depends on the core module, and it, as I've said, contains only the UI code. Next up, is the feature module. This is where it gets interesting. So a perfect example of a feature module would be an login flow. You have probably seen a login flow, I hope, sometimes in your career. Okay, cool. So a login flow usually consists of several screens, which has logic that is tightly connected in between those screens. You can also have a register as well in there, and you can place it inside of a building block called module, and you can name that login. What is now interesting is that you can use components which you've created and placed in core and core UI. But unfortunately, our apps don't consist only of login flows, do they? We would be done in a day if they did. We need to think in a higher dimension. We need to think about more features. And by using this kind of architecture, we can. We can add as many feature modules as we want. And one thing that I hate to say, but I do need to say, is that these modules shouldn't be neither too grained nor too bulky. And the reason I hate to say this is that we as engineers love when there is an upper limit and a lower limit, when we can specify something is too big or too small. But in this case, there really isn't a limit. This is something that is specific to each project, and that is something that you will figure out on your own as you try to and you work on your modularization. So now that we understand what are the building blocks and what are the types of building blocks with SPM, let's see how the code behaves when we make changes in that code. So let's say that you get a request to basically change a color of the background color of your login screen. Okay? It should be a one-liner, right? And you would basically just change that color. And let's say also that you've previously compiled and built the project, which is something we always do after our breakfast, brunch, lunch, dinner, and then we realize it's too late, and then we start working. Yeah, just kidding. So you've built your project, you decided to make a one-liner change, and the place you made it in is in a feature module. The thing that gets recompiled when you rebuild the project again is only the feature module, because SPM uses internal caching after you've built the project previously, and if you haven't changed any code in the modules, SPM uses that cache internally. What comes naturally to question is what happens if we change something in a core UI module? Let's say that we add another parameter in the initializer of our primary button configuration. Well, if we do so, what would need to be recompiled is obviously core UI module, but also all the other modules which use its functionalities, because it needs to be checked if that new thing that you've changed has to be implemented in those modules as well. Okay, perfect. Next up are two big no-nos. So, as you can see, we are starting to form somewhat of a tree structure. You have your most important modules at the top, and then you have your feature modules at the bottom that spread out. What is important to note is the way that they depend on each other. So we can see somewhat of a vertical dependency. What is a big no-no is to create dependencies in between modules which are in the same hierarchy level. Because if you do it once, you will do it the second time, you will do it several times, and it will most likely result in a circular reference, which you really don't want when you create a modularized code base. Another thing which will result in a direct circular reference is if you create your dependencies in a downstream fashion instead of a upstream fashion only. Perfect. Now that we understand what the building blocks are, now that we know how the code behaves when we make changes to it, now that we understand what are the big two no-nos, let's go to a 4-step cookbook which you can use to modularize any project. So, first thing I highly suggest is to learn about SPM. learn about that tool. I've given you the introduction to it, but it is now up to you when you get on your laptop to kind of learn more about it and to see how you could apply it to your project. Second step, which is really important, is to strictly define your feature modules before you even start modularizing. This will help you to know upfront in which way you want to separate your code. And what will happen naturally is the third step, because you will see several components which are either being copy-pasted or which are reused in different folders. And then you can see that they could be extracted in a core or any kind of parent module and reused in the feature modules. And the last thing that you have to do is roll up your sleeves and do the heavy lifting. Modularize your code base. It will be easy, right? Well, it may not be so easy, because you will encounter hundreds of errors, that's for sure. But it will all be worth it for that one holy build succeeded. And it was at this moment that me and my team felt the relief you felt once you exited the maze. And this is the perfect time for me to answer those two questions that we asked previously. First of them being, what does the maze represent? Well, in our case, it represented us being in a situation where we need to make a lot of decisions without getting the instant feedback if we are doing it right, but believing that somehow we will get to the end goal, to the build succeeded. An even more important answer is, who told us to go left or right? Well, it was the knowledge, the voice at the back of our head that we've gained when we did our first 3 steps of the cookbook. When we learned about SPM, when we decided how we will divide our feature modules, and then when we decided what components are reused and then put in Core UI. After we've done this great preparation, we were going through the maze, through the labyrinth. We were moving files from one module, from one folder to another. We were creating public instances, private instances, and so on. But at the back of our head, we knew exactly what we were doing. We weren't wandering around. And that's what helped us to get to the end of our maze. And once we've got there, our iOS project structure looked something like this. We've had our core module, Core UI module, and then 11 feature modules. And finally, a pull request was created with 23,000 lines of changes. I strongly advise you not to do this unless you notify your colleagues up front. They will for sure kick you out of your team. But if they all know about what you'll do, you can create that pull request. And what you'll probably notice is that the project PBX profile took the most damage. It almost got reduced to 0. And the reason for it is because SPM now handles the way files communicate with each other internally. And there is no need to maintain that in the project PBX profile, which was a great win and a big pro for us regarding the modularization. And now there are a lot of more pros for this approach. Unfortunately, this talk isn't long enough to cover them all. But we can focus on the few cons that you might encounter, and you for sure will encounter, if you don't do those first 3 steps right. So it will for sure be time-consuming if you don't know what you're doing, if you don't get the knowledge of SPM. It will, of course, you will get a lot of modules inconsistency unless you predefine the way you will structure your modules. And finally, you will have circular references if you don't follow those 2 big no-nos. And now, if you do everything right, if you do your preparation right, at least in our case, all of the problems we've mentioned before disappeared. And we were happy. You know, we reached that relief moment. We liked the way our iOS code base looked now. But now we were thinking, is there a way to maybe apply this knowledge, to use this knowledge of modularization on a bit more abstract level? So we decided to take a step back, and we started to look at the entire project code base, not only the iOS part. And we realized that there is something we can do, and something we can do with this tool specifically, with SPM. And that's what we will cover in the next chapter, metamorphosis. So, just a quick reminder for that one decision we did a couple of years ago. So we decided to use Kotlin multi-platform in our project. I would just like to ask all of you that have worked on a project which uses Kotlin multi-platform to please raise your hand. OK, I see several hands up. And for the rest of you, which may not be so familiar with the concept, Kotlin multi-platform is a tool which you can use to write business logic, and you can basically then distribute it to both iOS, Android, web apps, and so on and so on. This is not a sponsored talk. So we'll stop there regarding the KMM. We'll just go into the way our project was set up. So we've had our iOS app and our Kotlin multi-platform app, both placed in the same repository. And it started to get messy. Our project started to grow. There were a lot of colleagues working on this project, and there were a lot of daily actions that were happening on the project. So we decided to apply the knowledge that we've used regarding SPM, and we realized that it may be possible to separate iOS project in its repository, to separate Kotlin multi-platform project in its separate repository, and then somehow use SPM to give the support of Kotlin multi-platform to the iOS project. And so we did. We've separated those two repositories in functional components, and then imported Kotlin multi-platform into the iOS project. And this was done in a way that we will explain in the next slide, where we will see the entire structure of our entire code base. So our iOS project became somewhat of a child module, so to say, to the Kotlin multi-platform part, which we used a custom script to generate XC framework from. And then this XC framework was actually an SPM library that we were able to implement in our import in our iOS project, like any other dependency that you import in the project through SPM. And now at this moment, we were really happy with what we had. We were happy with the entire project structure. We finally decoupled Kotlin multi-platform from the iOS app. We also decoupled iOS app into several submodules, and it was now really easy to work on the project, even though there were a lot more developers than at the very start of the project. The next thing we'll look at is the legacy, the raw numbers, what were the result of our process of modularization. So the client didn't lie to us. Project X, at least the iOS part of the app, 1.5 years after modularization, continued to grow. A lot new features came out, but they were a lot more scalable, and it was very easy to work on the project, no matter how many developers worked on it. And let's check the numbers. So our local clean build times, which were previously around 3 minutes, were reduced by 55%. Our local incremental build time, which was previously 14 seconds, was reduced to 8 seconds. And now I know that many of you will say, wow, all of this for 6 seconds, like, great job. I mean, you can look at it from that perspective, but the perspective we look at it from is that you do how many incremental builds when you work on a project on a daily basis? 30, 40, maybe even more. And it's not only you that work on a project, it's your colleagues as well. And you also don't work on a project just in a single day. It must be measured in weeks, months, years, right? And when you look at it from that perspective, these time savings start to sum up and to result in something that is really useful for the project itself. And finally, our biggest pain point, our CI/CD build time, which was 30 minutes long, which I know that probably some of you here are thinking, half an hour, rookie numbers, our CI/CD build times last much longer. okay, it makes sense. But I also suppose, or at least hope so, that your projects are even bigger. Otherwise, you do have a problem. You understand that? Okay. So the CI/CD build time for the size of this project was too long, and that was one of the main reasons we went into the modularization process. And after modularizing the iOS part, after removing redundant code, after removing the duplicated code, after creating reusable components, it was reduced by 27%. And after we've removed Kotlin multi-platform from our repository, moved it to another repository, our iOS builds were only 8 minutes long. And now we're talking about a great time saving. But I do need to say that this isn't the cost saving. So our builds really do last shorter, but there is still that Kotlin multi-platform part, but that part is built on a different CI/CD. We can decide when we want to build the Kotlin multi-platform CI/CD workflow, and then attach a version number to it, and then create, let's say, several iOS builds which rely on that version. Meaning we can create one Kotlin multi-platform build and use it in several iOS builds, which was a great win. And when you look at it from that perspective, you see great time savings, and at least in our opinion, this whole process was worth it. Unfortunately, we didn't have these numbers before we were starting out, because if we had, it would be much easier to convince our project managers to do it even sooner. So I strongly suggest that you either take a picture, that you kind of remember what we were talking about, and that you suggest the modularization process to your colleagues, to your project managers, because there are clear implications that it can improve your project. And if there is anything I would like for all of you to take from this presentation, it's not strictly relying on the modularization. It's about you being able to enter any kind of maze with any kind of tool, not be afraid to do it if you do your preparation right, and you will for sure have the voice at the back of your head, which will lead you to go left, to go right, and eventually lead you to your exit. Thank you.
Thank you very much.
Okay. And just one quick thing before we move to the Q&A. After I've done this talk at Swift Leads 3 weeks ago, I've received a lot of questions about additional materials about this. So I'm currently working on a course where we will together modularize a existing monolith project and learn more about modularization. So if you are interested, I decided to give a 50% discount to everyone who is at Pragma Conference. So you just leave me your email, and I will send you the promo code.
Very cool. Do we have any questions? Peter, in the front over here.
Thank you very much. I think it was a very good speech. Just one question about cross-cutting concerns like analytics, which should be in all of the features, but if I understand well, the core shouldn't rely on anything else. Okay. How are you managing this one?
I'm not sure. Can you please explain it a little bit?
Let's say we have analytics, which is kind of cross-cutting concern, so all features should have the analytics.
Okay.
In theory, it should go to the core, but usually analytics is not that you are by your hand. You are using some external dependencies here.
Okay.
How are you handling that part?
So anytime you have a tool which you do want to use in separate modules, but it also belongs to core, you can always create some kind of support for it in the core, like some kind of extension or a singleton, which you can then reuse from your features and access it from your feature specifically. And then you can provide the information from which feature you're accessing it from, because I suppose that's the important thing for the analytics part you asked about. Is that okay?
Okay, thanks.
No problem.
Thank you. I think we had a question here in the front as well.
Hello. So I would like to ask, because you said that by default when we create an iOS app, it's a monolith, and that's true. But can we use SPM to create a fully functional either UI kit or Swift UI app? To use only Swift UI without, let's say, we can use Xcode to code later on, but can we use SPM to, how to say, bootstrap our project? That's the word.
Yeah, I'm pretty sure you could. It's something that I'm looking into right now to like make this entire process even more streamlined when we are starting a new project. But it's something that I didn't wrap up completely, and I'm still not completely comfortable about, talking about.
I understand. I also tried it, but it was when SPM was much less mature. So I just wanted to ask if you knew something. Thank you.
Yeah, no problem. Thank you.
Was one question there, and that will be the last question, and we need to move on.
Thank you, Anthony. It went great, as you asked before. Thank you for the presentation. The question about the project file that you mentioned, many lines.
Yeah.
Did you consider to generate with Xcode or Twist something to generate the project file? And if yes or not, why?
So we didn't do that because automatically, as you create modules, by like when you create a module and you move file from your, let's say, initial structure of the app to that module, the information from the project PBX profile disappears automatically. So you don't need to do that by hand. It basically disappears, as on the go. Does that answer your question?
Yes, in some way. I mean, just to avoid those conflicts when you merge stuff.
Okay, we can catch up after the conference as well, so we can.
Please do. And also, there was another question over here. Go find each other afterwards.
Of course.
Yeah. Thank you very much.